All right, today we're going to talk about work and power, what the difference is, and how they're related. So, work is the energy uh, transferred when a force displaces a mass. Now, there's two things that are important here. First off, we're transferring energy um, with a force or through a force. So, we have to have an applied force. Second thing is we must displace a mass. What that means is I can have a force on a mass, and if the mass does not move, no work is done. I must displace or I must move that mass. That's the two things. Power is the rate at which work is done. So, rate is important here. We're taking work and we're completing it at a rate or in an amount of time or a period of time. We generally transfer work and power through either mechanical, electrical, or fluidic means. Okay. Work, W, is equal to a force times a distance. Okay. Work in the United States is measured as foot-pounds. Everywhere else it's measured as Newton meters. Power measured in foot-pounds per second. Everywhere else it's joules. And time is measured as seconds. So 1 horsepower is equal to 550 foot-pounds per second. I don't believe that's a minus, I believe that's foot-pounds. So here are our three formulas. Work is equal to force times distance. Power is equal to work divided by time. And horsepower is equal to power divided by 550 foot-pounds per second. Okay, if Jessica moves her 112-pound body up 8 feet of stairs in 2.3 seconds, how much work did she perform and how much power did she use? Okay, the first part is how much work did she do? Well, we simply take, I know this is a little hard to read, but we simply take 112 pounds and multiply it by 8 and we get 896 foot-pounds. The next thing we do to find power, we take the power or the work that we just calculated and we divide it by the amount of time. So 2.3 seconds divided into 896 foot-pounds is equal to 390 foot-pounds per second. If we convert that into horsepower, 390 foot-pounds per second, and then we take this formula, that conversion. So we're going to multiply that by 1 horsepower is equal to 550 foot-pound seconds. And we get, notice that the foot-pound seconds cross out and we end up with just the horsepower here. So 390 times 1 divided by 550 is 0.71 horsepower. Okay. An escalator moves 84 people per minute from one floor of a mall to the second floor. The mall's floors are 24 feet apart and the average person weighs 154 pounds. How much power does the escalator need? Okay, we start off with, we need to have pounds. Here we need to have total force, which is equal to 84 people times 154 pounds per person. And then we just multiply that by 84. multiply these two together, and that gives us our pounds. Each floor is 24 foot between the two, so we multiply those two and we get 310 464 foot-pounds. To find power, we just divide that by how long it takes to do that. In this case, 60 seconds. So 310,464 foot-pounds divided by 60 seconds is equal to 5,174 foot-pounds. But if we're trying to find a motor, how big a motor we've got to have to do this, we've got to convert it to horsepower. So we take that number and multiply it by 1 horsepower is equal to 550 foot-pounds per second. Our foot-pounds per second cancel out and we end up with horsepower. And of course that equals to 9.4 horsepower. Now understand that this 9.4 horsepower is at a 100% efficient machine. There we go. So while there's no such thing as a 100% efficient machine, we can use this as a base, as a starting point. Okay, that is how we calculate power and work and horsepower.